For this lesson, let's talk about direct variation. To start with, here's the definition. We say y varies directly as x to mean y is equal to some number k times x. So here k is a constant, and it just can't be equal to 0. So down here, I have the equation y equals 3x, which looks something like this. So here we could say y varies directly as x. Well, what does this equation tell you about the two variables x and y? The idea is, if you choose a number for x, like, well, let's say 1, and you solve for the corresponding y value, well, y would be equal to 3 times 1, and that's equal to 3. So when x is 1, y is 3. If you choose a different number, like maybe x is equal to 2, and then solve for this next corresponding y, well, it's going to be equal to 3 times 2, and that is 6. The thing to note is that as x increases, so does y. In fact, it increases proportionally. If you double the x, then you also double the y. So that is what we call a direct variation, and that means you can connect the two variables in an equation that looks like this. One other thought, the reason that the constant can't be 0 is you can't have an equation that looks like y is equal to 0 times x and call this direct variation, because if you let x equal 1, well, then the corresponding y value is going to be 0 times 1, which is 0. But then if you compare this to, let's say, x is equal to 2, okay, y is going to be 0 times 2, which is, okay, again, 0. The problem here is, okay, you're doubling the x's, but the y's don't double. In fact, they remain the same. So for that reason, we just don't allow 0. Any other non-zero number will work. Let's get some practice with this definition here in example 1. So first we're going to suppose y varies directly as x. Okay, when y is 15, x is equal to 3. So we know these two things as facts. Can you figure out the value of y when x is equal to, let's say, 27? All right, the approach for this problem is to first note that, well, if y varies directly as x, you are allowed to write y is equal to some non-zero constant k times x. If you know this value of k, then if I give you a value of x, you can solve for its corresponding y value. So step 1 for this process is going to be, can we figure out what the value of k is equal to? And that's where this piece of information comes into play. Well, you can put 3 in place of x and 15 in place of y. The only thing you won't know is k, and that means you can solve for it. So I'll put 15 in for y. I'll put 3 in place of x. Clearly you're going to solve for k by dividing both sides by 3, and you get that k, the constant, it's definitely not 0, but it's equal to 5. So this actually gives you the equation as how x varies directly as y. Y is equal to 5 times x. All right, so I first set up my equation. I solve for k. I wrote this thing here. I can now figure out the value of y when x is equal to 27. All I have to do is put 27 here to get my answer. So y is equal to 5 times 27, and that value is, okay, 5 times 20 is 100, 135. And this is the answer to the problem. Let's see if we can use this abstract definition of y varies directly as x to solve a problem that has some context with it. So here we go, in example 2. When you swim underwater, the pressure in your ears, and we'll measure this in pounds per square inch, we'll say this varies directly as your depth in feet, so like how far you go under the water. We know at a depth of 20 feet, the pressure is 8 pounds per square inch. Well, what would the pressure be if you went down to 87.5 feet? You can use any variables you would like. Maybe instead of using x's and y's, I'm going to use the variables P for pressure and D for the depth. So your equation this time, we won't again use y's and x's, but we'll say the pressure varies directly as the depth. So to solve this, it's like you want a formula where you would plug in 87.5 for D to solve for P. The reason you're not allowed to do that first, because we don't know K. However, here we have a connection between the pressure and the depth. When we are 20 feet deep, the pressure is 8 pounds per square inch. I'm going to take this information, put it into this formula, and solve for K. So we get 8, the pressure, is equal to K, which I don't know, times the depth, which is 20. Just like last time, same idea. I'm going to divide both sides by 20 to solve for K. And, okay, I'll get a decimal for this. Let me see. On the left, we get 0.4, and that is equal to K. It's okay that it's not an integer. A decimal is totally fine. It's not 0, so great. I have an equation that I can use for any variables. I'll write that over here. Pressure is equal to 0.4 times D. To now get my answer, I'm going to put 87.5 in place of D and solve for P. So that's 0.4 times 87.5. I'll get my calculator here. 0.4 times 87.5. Okay, the pressure is going to be 35. And the units are important here too. So this 87.5, that was your depth underwater. And 35 is going to be the pressure, and that's pounds per square inch. So I can write that as pounds divided by inches squared. And that is the answer for this problem. And let's try another variation on this idea. So here in example 3, this says y varies jointly. There's other language. You can say directly, you could say jointly, you could say proportionally. All of those are meaning the same thing, but I'll just say y varies jointly as the cube of x. Now, this language is, again, slightly different, not just from the word jointly, but this term, the cube of x. You know, what does that mean? Just starting there. I know y is equal to some constant times x means y varies jointly as x. But this terminology of the cube means you have to slightly change this equation. The cube of x means you put a 3 in the exponent. So here y varies directly as x is cubed. So just being careful here, the formula is slightly different. Okay, that being said, now we have some more information. We're told that when y is equal to 1,372, x is equal to 7. What is the value of y when x is equal to 2? The idea is the same. I'm going to use this information to solve for k. And then once I know k, I can use that formula to solve for this y. All right, so let's do that. For starters, I know if I put 1,372 in place of y, and I put 7 in place of x, it's going to look a lot like what we've done before, but the only difference is before I divide by 7, I have to cube 7. So let's do that. 7 cubed is 343. So I'm going to say, well, on the left I have 1,372, and this is equal to k times 343. This is the number that I'm actually going to divide to every side. And when I do this, I'll do that in my calculator, 1,372 divided by 343, I get 4 is equal to k. This means I now have my equation. Y is equal to 4 times x cubed. I will put 2 in place of x and solve for y. Y is equal to 4 times 2 cubed. Well, 2 cubed is 8, and 8 times 4 is 32. And that is the answer for this problem. not only can you have direct variation where as one variable increases, then so does the other, but you can also have inverse variation. So what does that mean? I'll again start with the definition of it and then look at a couple of simple examples. So we say y varies inversely as x to mean y is equal to some constant not multiplied by, but divided by x. And for the same reasons, this value k has to be non-zero. It's got to be some non-zero number. So the equation that I have right here means y varies inversely as x. So if you want to investigate what's going on, again, you could like put in some numbers. Like, oh, well, if x is equal to 1, can I solve for the value of y? And, well, clearly the answer is yes. You would just take 2, the constant, and divide by 1, and you get 2. All right, that's great. But if you then, let's say, increase the x value to 2, what happens to the y value? Okay, here, it's going to be 2 divided by 2, which is 1. So here, as x goes up, the y values are going down. And that's what we mean by inverse. When we had direct variation, if both of the variables, as one variable increases, then so does the other. Here, as one goes up, the other goes down. In example 4, let's suppose that y varies inversely as x. When y is equal to 12, x is equal to 3, can we use that information to figure out the value of y when x is 8? I think this will be pretty similar when we had direct variation, but let's see if there's any differences. To start with, when you say y varies inversely as x, you are saying this, y equals some constant that's not 0 over x. We can now solve for k by using this information. I will put 12 in place of y, and I will put 3 in place of x. So this time, I'm not dividing both sides by 3 to get the constant by itself, but I'm multiplying 3 to both sides of the equation. So that is, in this step, I'm going to multiply both sides by 3. It'll cancel the 3 on the left, leaving me with just k. But on the left side of this equation, I have 3 times 12, which is 36. And this is my value of k. To answer the question, I'll set up the formula again. It's y is equal to 36 over x. When x is 8, what is the value of y? I can get this information by simply putting 8 in place of x. So what happens when I divide these two numbers? I get that y is equal to 4.5, and that's the answer to this problem. So here, the x value increased, and the y value was at 12, but then it dropped down to 4.5, and that is something I would expect to happen if I had inverse variation. Okay, here in example 5, we're going to look at a problem that has some context. This one says the water temperature of the ocean varies inversely as the water's depth. And that makes sense. As you go further down into the ocean, I would not expect the temperature of the water to increase. I would expect it to decrease. All right, so at a depth of 1,000 meters, the temperature is 8 degrees Celsius. What is the temperature at a depth of 2,000 meters? So to start with, I'm going to define my variables. It's fine to use x and y, but I guess I'll use maybe T for water temperature. I guess you could use C for Celsius, but I'll just use T for temperature. And then maybe I'll use the letter D, again, for the depth. Again, x and y, that's fine, but I'll just use these. If these two variables, they vary inversely the way I have it set up here, that is, the temperature varies inversely as the depth, I need to solve for k. And I can use this next sentence to figure that out. At a depth of 1,000 meters, the temperature is 8. I'll put that information into the temperature and D. So that is, when the temperature is 8, I would divide by 1,000 meters. To solve for k, I would multiply both sides of this equation by 1,000. Because on the left, the right, the 1,000s cancel, leaving with k, and we have 8,000 on the left side of this equation. I have my formula. T is equal to 8,000 divided by D. I solve for k, and I put it back into the equation. So what is the water temperature at a depth of 2,000 meters? Probably not a surprise here. What we'll do is we will put 2,000 in place of D, and let's see, I can cancel all those zeros. 2 goes into 8 4 times. And so here the answer is 4. And for what? That is 4 degrees Celsius. And in this last example, example 6, let's suppose y varies inversely as the square of x. Again, slightly changing the language in the definition of inverse variation. So here, to say y varies inversely as x is to say y is equal to k divided by x. But we have this language here that says the square of x. So this formula technically isn't correct. But when you say the square of x, you literally mean just put a square on the variable x, meaning the equation that you want to work with is this thing. So here it is. For this formula, when y is 2, x is 5, can you solve for y when x becomes 10? Okay. I think what I'll do is plug this information into this formula and see what happens. All right, when y is 2, x is equal to 5, but we have to square that 5. So 2 is equal to k over 25. If you want to solve for k, you have to multiply both sides, not by 5, but by 25. On the right, the 25s cancel, leaving the k. And on the left side of the equation, we have 50. And this means we have our formula. The formula is y is equal to 50 over x squared. I now can solve for the value of y that we're looking for. When x is 10, what is y? So I'll put 10 in place of x and go from there. Okay, y is equal to 50 divided by, okay, here we are putting only 10 in place of x. But you have to square it first. And when you square 10, you get 100. And if you take 50 and divide that by 100, that's 5/10, or simply 0.5. And that is the answer to this problem.